In this presentation, we're going to take a look at how we solve this wiring diagram and determine the number of conductors that would be required in each one of the conduits. You would say, well, why the heck would you want to know? Well, often you have to size a conduit for the number of control conductors. However, in this case, I suspect we'll have so few conductors that really the pipe size won't be of much concern. But what is of concern is that often pendant push button stations are actually connected back to a junction box or hung from the ceiling with a flexible cord. And in those situations, you have to know how many conductors are in the flexible cord so you can order it. You can't just decide to put another one in later. So first thing we want to do is to label NEMA 2, NEMA 3, NEMA 1 on the diagram. This tells me where my terminations are going to take place on the starter. Down here, I also want to label NEMA 1, 2, 3 so that I know I have a few control connections down there. The next step is for me to sketch a basic push button for each of these pendant stations. I've got a normally closed, which is a stop, a normally open, which is the start, and then this combination push button, which is the jog. And I'm going to do that for each one of the pendant stations. That's really the only way to guarantee that we are going to be able to account for every single wire and connection. Now, the diagram itself is going to look really messy by the very end, and that's okay because we need to have a physical wire in each location so that we can track it. All right, so each time I wire something on the diagram down here, I will cross it off or highlight or overlap it up here. And where we're going to start is on the left-hand side of the diagram, and that's going to be from NEMA 1 to stop number 1. So NEMA 1 is here. I'm simply going to go all the way up, out, and over. And notice that I've actually terminated into the left-hand terminal of my stop push button, left-hand terminal of my stop, and that will simply make things easier for me as I proceed through the diagram. The more consistency I can apply between the two diagrams, the easier it's going to be. All right, so out of stop number 1 into stop number 2. So out of stop number 1, notice I'm coming from the other terminal because the other terminal on the schematic, and I'm going all the way up and over to my second stop push button right here. Now we're going to come out of stop number 2 and go into stop number 3. So I'm coming out of stop number 2, up and over, down into stop number 3. Now we have a parallel connection for a portion. So from the normally closed or the stop push button number 3 to jog number 3, I'm actually terminating to the normally closed right-hand side to the normally closed left-hand side. So these two terminals here are this one, there's my stop push button, and this one, there's my jog. And those simply connect together. Now I also have this connection down here, and that is a connection between the top and the bottom of my jog push button. All right, well, let's continue on. And it looks as though I'm going to connect jog number 3 to jog number 2 on the normally closed side. So jog number 3 to jog number 2. Go all the way down, starting to get a bit messy. And there we go. Now we're also going to connect jog number 2, the normally open and normally closed left-hand side of the push button, like that. And now we're going to continue from jog number 2 to jog number 1, again, coming out of the appropriate terminal and going all the way over to the jog number 1 push button station. There we go. All right, so now we've done jog number 2 to jog number 1, and then jog number 1 again has this jumper between the normally closed and normally open, which is that. There we go. So that's all done. Let's now go from jog number 1 to one of the start push buttons. Now you'll notice they haven't identified which start button it is. Because they're all in parallel, it really doesn't matter. So to make things most efficient, I'm going to go from jog number 1 into start number 1, and then I'm going to do start number 2 and start number 3. So jog number 1 into start number 1. That would be this connection right here. So out of the normally closed into the left hand normally open of the start. There we go. And now from that same terminal, we're going to go to start number 2. So start number 2 is going to be here. I'm going to go overlap. There we go. Give me a little more room. And we're going to go all the way out. I'm going to go all the way to start number 2, which is right here. And then I'm going to go from start number 2 to start number 3. Now, do I really need to run from the terminal of start number 2, like here, and go back up and then over? Or can I just make a splice in the junction box? And the answer is splice. So we're going to make a splice, and we're going to connect to the third push button. All the way down and in. Now, we're missing one connection, and that's to NEMA 2 on the starter. In the same way that we did a splice between 2 and 3, let's do a splice again to this same conductor. And this time, the splice is going to take us to NEMA 2. All right, so now let's take a look at the other side of these start push buttons. It looks like start push button 1 connects to a whole bunch of different places. Push button 1 connects to NEMA 3, connects to push button 2, push button 3, jog 1, jog 2, and jog 3. They all connect together. And what this tells me is that we're going to have a number of parallel connections. So I got to figure out what the most efficient way is for me to connect all of these together. So I'm going to choose to take start 1 and connect it all the way over to jog number 1. Start 1 to jog 1. Now, the reason I'm choosing to do that is because jog 1 and start 1 are in the same pendant. So here are the two terminals that are going to connect together. Start 1, jog 1. So that's essentially me doing this. And that also means that all of this is connected. Now, this same push button has to connect to NEMA 3. So from that same terminal, I'm now going to go to NEMA 3 on the starter. So I come up, out, and go all the way over, and NEMA 3. Now, push button 2, the start push button, also connects to push button 1 and jog 1, but also NEMA 3 and jog 2 and jog 3. Like, it connects to everything. So why don't we do the same thing we did with the start push button number 1, and let's connect the jog number 2 to my second push button right here. Now, I'm doing that because it's in the same enclosure. Now, I also have to connect it up to NEMA 3, or at least one of these wires. Now, remember, NEMA 3 is right here. So could I make a splice in the box and just run another wire down? And the answer is yeah, for sure. So I'm going to make a splice, and I'm going to run my wire all the way over to my start push button right there. All right, the last one, there's my third push button and jog number 3. So let's do the same thing we have with the previous two examples. We're going to go all the way over to here. And remember, we connected push button 2 back to this wire. We're going to connect push button 3 back to this wire by doing another splice. So there's a splice. We're going to take the wire out and go all the way across down into my start push button. And of course, we can't forget this connection here either, the connection that connects the jog back to the start push button. So this is a rather complex wire count, and that's because often you get complex controls out in the field. No matter how complex it is, we still need to be able to figure out what wires are necessary. Even if we don't quite understand how the control is to function, it's necessary to be able to determine the total number of conductors. So for conduit A, 1, 2, 3, 4, 5. For conduit B, if we include the power conductors, 1, 2, 3 plus 3 power conductors would be 6. Conduit E, 1, 2, 3, 4. Conduit C, 1, 2, 3, 4, 5, 6. And conduit D, 1, 2, 3, 4.